So I'd like you guys to do as long as we're here. Okay, I want you to do a practice for the post test that's coming up next week on vocabulary. The post test is, where am I here? Okay, post test. Post test is one that I got to share. Post test is something that is coming up on 10 vocabulary words. Want to see if you've remembered, okay, your vocabulary words. So if you go into the modules and click on week 3, where are we? Week 3, and go to vocabulary pretest practice. Okay. Let me see if this works for you. Tell me if this works. Some people said this wasn't working. Hi, Oz. So go ahead and get into that. I give you 8 minutes till 2 o'clock to get that quiz done. All right. It is taking responses. If you don't get an 8 out, if you get an 8 out of 10, I will give you 10 points. That means you passed. All right. So you've got till 2 o'clock. So 7 minutes. And we'll get started with an introduction to acceleration. If you'll notice, where is it here? Okay, the pretest says if you don't do well on it, you can look at week 1, and it says use the vocabulary notes and then copy the definitions and answers on paper with drawings that I've left for you, and then take an image of that and then post it. I'll give you the 10 points. But if you can get 8 out of 10 in the next 7 minutes, you don't have to do that assignment. You just have to post your score. Okay? All right, so you have 7 minutes, 6 minutes now, right? And I will be closing it from that. Once I close it, and if you don't get it in by then you are, and this is 10 points. It's not a bonus. Okay, it's actually 10 points this week. Points are 60 points instead of 50 for this extra 10-point pretest. So I'm going to put this on pause. All right, so let's start this off. Okay, so that's not where we wanted to go. But I started at the beginning. All right, so your participation is greatly appreciated. Okay, so introduction to acceleration. So acceleration can seem like taking a jump to light speed, but we can't go that fast, but we can really move around quickly. So we're going to explain how acceleration works for you guys. You've all felt it before. You probably did not give it that explanation that we use. But remember, just a review from last week, a scalar and vector. This is what seems to be the hardest thing. I keep asking people which is which, and they have trouble remembering. So remember, a scalar is something that only has magnitude or a number. It can have units like 50 meters per second. And I always think looking like this, where I say that the scalar, let me go put my pen here. Scalar, I can always know that scalar is speed, okay? Because speed does not have a direction. Where v for vector is the same as velocity, all right, you might want to check, Mariana. It's not something that you're not supposed to be able, your math lab shouldn't be during class, right? I'm sorry, Madison, I have to get started. I only had the 2 o'clock thing there. We only had a window there. So I'll take a look at what you got. Okay, so velocity and vectors, right, has magnitude. That means it has 50 meters per second. and it also has a direction: right, left, north, or south. So that's how I remember speed is a scalar. Scalar means only number, doesn't have a direction. So those are the things, both describe the motion of an object, but one has the direction in it, velocity does, and scalar speed, you can talk about any direction at all. Okay, so let's take a look at, if you knew what I was just talking about, let's start a poll here. All right, so A is, let's go here, scalars. What is a scalar quantity here? Is it A, speed and distance? If speed and distance don't have direction in it, then it is a scalar. Or is it B, displacement and velocity? All right. So remember I said what I said about that. So let's see how many people are here today to vote. A or B, which do you think are scalars? Distance and speed, or displacement and velocity? Thanks, Mariana. Thanks, Jasmine. Thanks, Ariana. How about you, Zaria, Tanisha, Shayana, Renaya, Madison, Kamara, Jeremy, Joey. Where'd Joey go? Joey already did that, didn't he? Yeah, Joey did. Okay. Janaya, Christian, and Bradley and Oz. Come on, guys, don't be the ghosts that I always have in this class. If you're here, participate, please. If you're here, please participate. There's 8 out of 16 of you, should have 16 out of 16, right? You know, it's anonymous. You don't have to, all I'm doing is saying hello, that you've got a response in there. Thanks, Haley. All right, so 8 out of, everybody got that right. So distance and speed are scalars, so vectors are displacement and velocity. Good job, you guys were listening. I appreciate it, or you already know. That's even more important. Okay, so scalar, distance, 45 feet, 12 meters, 10 miles per hour. So some people were having difficulty knowing the difference between speed and distance. So when you have that slash mark there, that means per for every hour, 10 miles for every hour, 200 kilometers for every second. But displacement has this one added piece in there where it says west or left or north. So you can have a distance with a direction that makes it a displacement. Okay, if you have a distance with no direction, then it's just distance, right? It's a scalar. All right. So how are speed and velocity different? Tell me, there's 2 things that you can think about. Start a poll, right? How are they different? How are they different? Okay, and how are they different? 2 F's and different. All right, so let's type a response, start a poll. How are speed and velocity different? We just talked about it, right? One has only magnitude, the other one has direction. Which one has direction, which one doesn't? So that's what you have to decide, right? Does speed have direction, or does speed have no direction? Does velocity have direction, or does velocity have some direction? This is a toughie. Trying to remember speed. Good job. Thank you, Zuria and Renaya. Thanks, Adriana. Ariana, thanks, and Jasmine. Thanks, Lennon. Excellent. All right, that's a tough one. 6 out of 17. Yeah, you guys are right. Velocity has a direction: plus, minus, up, down, left, right, north, south. And speed doesn't. No direction. No direction. Okay, and this is also a scalar. And velocity is a vector. So we're going to talk about acceleration now. Acceleration is a bit different. Okay, so velocity includes speed and direction. Difference between speed and velocity. Velocity includes direction. And you guys said that. Excellent. So here, give me an example of start a poll. What is acceleration? What is acceleration? I'll give you a hint. And it's different from velocity. Okay, so let me show you why. Here's constant velocity, and I'll give this into so constant velocity, I'm in the car, and this is what it feels like. Nothing. Constant velocity, I got the cruise control on, but then hit the accelerator. Whoa, I'm being pushed back in my seat. Stop really hard. Wow. Turn right really hard. Whoa. Turn left really hard. So you can feel the effects. So what's happening? What's happening? All right. Thank you, Lennon. What else? What else? What makes me go, oh, like that? Okay, that speeding up makes me go like this. What makes me go like that? What made you do that? I can tell you, in my day, when I was born, they used to think that the dad driving and stopping really hard, the mom could hold the baby in their arms in the front seat. But what happened without the seatbelt, mom and baby go through the window, right? Stopping too fast, right? Right, exactly. Stopping too fast can cause that. How about this? What makes this go? What happens there? That's an acceleration too. What's going there? Anybody know what's happening there? Oh, Joey, you get to ride on horses. All right, fantastic. So what's happening there when I go like this and something's happening in the car and I can feel it. I hit the window because something happened. What happened there? Because I got speeding up, slowing down, going down the hill, stopping really hard. How about turning a corner? Turning a corner really fast is acceleration. Oh my gosh. Yeah, you feel it. Anytime you feel it, that's acceleration. When you get to constant velocity, cruise control is on, you don't feel anything. But when I speed up or slow down, whoa, man, that's so amazing. It's an experience and it can be frightening. Right, so let's take a look at constant velocity here. The person on the top is going constant velocity. You can see about the same speed all the way around. Maybe again, they probably didn't. They were already started walking, but normally we start accelerating. You can see this person on the bottom almost caught up with the person on the top. They go slower, then faster and faster and faster. So they're accelerating, right? So let's take a look at this when it talks about rates and velocity. So let me put my camera off here so you can see this a little bit better. So if you can see, when I draw this, velocity arrow is the same everywhere. So the reason it's the same everywhere is, like, let's say that's 5 meters per second, right? So this is another 5 meters or 10 meters I've gotten down the road. Here's another 5 meters. That's 15. So I'm covering 5 meters every second, and my velocity arrow is the same. So 5 meters a second, add another 5, add another 5, add another 5. But acceleration starts like this. I'm at 2 meters per second. Right, and I'm going to add 2 meters per second. So this is going to be 4 meters per second. It's going faster, and see my velocity vector arrow is getting bigger. Now I'm going to be 6 meters per second. So I'm going faster and faster and faster. 6 and then 8 meters per second. So I'm accelerating by 2 meters per second every second, 10 meters per second. So as long as I continue putting my foot to the gas, I'm going faster and faster and faster at a constant rate of 2 meters per second, 2 meters per second. I can accelerate without going 2 meters per second every time. I could go 2 and then 4, then 6 and go crazy like that. But again, we're just going to talk about acceleration that's predictable. Okay, so which car is accelerating on this one? Let's try this one here. Publish a poll. Let's start a poll here. Publish, start a poll. So A, B, or C. All right, so which? All right, which is accelerating? All right, so A, B, or C. Which are the ones that looks like they're going faster and faster and faster every second? Which one does? All right, several of you guys said letter C. That's great. C does. How about B? Is it overtaking letter A? Could B possibly be doing that as well? See how it's catching up with letter A? Letter A looks like it's being constant, but letter B is catching up, isn't it? Well, everybody's okay with C. Okay, number 1 is most likely going to be the constant velocity. But if you'll notice letter B, it's catching up with, it starts off slow and it keeps going faster and faster and faster. And by the end, it almost caught up. Letter C starts off even faster than about the same rate as letter A is. And then it's a little behind, catches up, goes faster. Okay, so it's B and C. Thanks, guys, for getting in there. Okay, so that's what it looks like. And again, if you look at the acceleration arrow, right, 1 meter per second is 15 kilometers per hour. At 1 second, at 2 seconds, we add another 15. That's 30. 3 seconds will make it 45. 4 seconds will make it 60. And then 5 seconds, it'll make it 75 kilometers. And notice the acceleration arrow, or the acceleration arrow, the velocity arrow. Sorry, so velocity arrow gets bigger and bigger. The green one is a velocity arrow. The yellow arrow they don't have in there. So you can see the arrow gets bigger, right? The acceleration arrow is going to be the same size, but we'll talk about that later. So acceleration is a rate of change of velocity. When velocity is an object changes, the object is accelerating. All accelerate to start moving, but right away the red car holds its velocity constant. The green and blue cars continue to accelerate. So let me ask you this question. Thanks for participating. I know it's the end of the day and you're thinking to yourself, oh man, I don't know. Is slowing down acceleration? Is slowing down acceleration? So let's go yes or no on this one. Let's get that one going. We'll get what do you think? Slowing down, okay? So remember, in acceleration, you feel acceleration. If you're speeding up, it pushes you forward. Does slowing down, push you back? It's a slowing down, push you forward. All right, 2 people said something. Thanks, Jasmine, Zaria, Joey, Lennon. Come on, Tanisha, thank you. Mariana, Tanisha, Kamari, Haley. All right, got 7, almost half of you guys. So most of you say yes, and that's true. It is true. All right. Deceleration. If the speed decreases, the acceleration is the opposite direction. So if it's going in the the same direction, it's going faster forward. If it's going slowing down, the acceleration is in the negative direction or in the opposite of velocity. We call that deceleration. So acceleration can be negative. You can see its car is slowing down, right? Let's see, I got a new person in here. Anaya, did I just see you come in? Who else came in here that I did not see? All right, I think it was just Anaya. All right. All right, so which image shows negative acceleration? All right, let's see what your opinion on this one is. Negative acceleration, right? A or B, negative acceleration. Is it the van that almost tips over? Negative accel. Is it A or B? What do you think? Negative acceleration, A or B? The lawnmower is going backwards, speeding up backwards, and the van is almost tipping over, stopping. I would be so scared to be in that van, that's for sure. Could easily tip right over. So a lot of you guys said B, right? And half of you said A and B, and you guys are both right. So it is negative acceleration is slowing down, and negative direction backwards speeding up is also negative acceleration. So, and it looks like this. So here is a velocity time chart. So we have speed plotted on the y-axis. So that's plus direction, plus speed, and it goes down to 0. So that's what that van looks like. It's going from plus velocity to 0 velocity, and the lawnmower starting at 0 acceleration and going in the backward direction faster and faster and faster in the backward direction. So they're both negative velocities. Okay, so is turning the corner accelerating? Well, of course it is, because you feel it. When you turn the corner sharply, you feel yourself being pushed, right? Acceleration occurs anytime the object changes how fast it's moving or changes its velocity, but velocity includes direction. So if an object changes its direction, even if it doesn't change speed, changing velocity acceleration is a change in velocity over time or changing direction. All right, so let's just summarize here. Any change in velocity, speeding up, positive, acceleration, and velocity both going in the same direction, changing direction, slowing down, velocity going in this direction, and acceleration going in that direction, or acceleration or going in the opposite direction is also negative acceleration. So to change may be due to an increase in speed, increase in changing speed, or decrease in speed. So you can see the acceleration as we get to the end, as it slows down, the acceleration goes in the opposite direction. Starts off going down, and acceleration and velocity going the same, and then it starts to slow, changing direction, and then it starts to slow down. Okay, so that's where we're going to stop right here today, ladies and gentlemen. Okay, so what we're going to do now, let me show you this. Okay. Do I have? All right, so what we're going to do now, and I forgot to load this up, but we're going to, see if I can get this loaded up fast. Got to upload this. So we're going to talk about, we're going to work on some assignments. Week 2, assignment 1 is overdue as of Monday, and there are quite a few people that didn't get it done. So what I'm going to do is I'm going to give you some time to either do it yourself. It's only 5 questions, right? 5 questions. I'll show you, or you can work with me and get the 15 points that way. There we go. Missing or low score, W2 assignment 1, 15 points. So in the shared notes, I will put your name, so the people that missed it. And then in the public chat, I will put the link to the big blue button that's in another course. Okay, so we can go over there. You can either do it yourself. Remember, you can do the acceleration bonus assignment today. You can do W3 assignment 1, right? You can do any of those assignments. You can do W2 quiz, which was due last night. So that's going to be a 0 today. So there's a lot of things you can do to bring your grade up, because we're going to add 50 new points from last week and then 60 points from this week. So let me do that right now. I'm going to put this on pause.